multiply secant x plus tangent x by secant x minus tangent x, then simplify as much as possible. So I'm going to apply the FOIL method here. It's going to be secant squared x for here. Then I'm going out here to multiply the outside terms. It's going to be minus secant of x tangent of x. Multiply the inside plus tangent of x times secant of x. Then the last minus tangent squared x. Okay, now let's take a look at what we have. Well, these two middle terms are going to cancel each other out because we have secant x tangent x and tangent x secant x. We can just use the commutative property of multiplication and say this is minus tangent x secant x and then plus tangent x secant x. And then you can see right here what happens is these just simplify out, and then you have the secant squared x in the front, and you have your minus tangent squared x at the end. So these middle terms simplify out, and you simply have secant squared x minus tangent squared x. Well, now we're going to apply a Pythagorean identity. I'm going to apply it to the secant squared x, because the secant squared of x equals 1 plus the tangent squared of x. So I'm going to substitute into here, and that will give 1 plus tangent squared of x minus tangent squared of x. So plus tangent squared of x minus tangent squared of x, that makes 0. And we're just going to be left with a 1. So secant x plus tangent x times secant x minus tangent x equals 1.